Welcome back, chemistry fans. We are going to work on the Unit 15 quiz dealing with batteries to try and get you some solutions for that. So let me share my screen. We will get started. Okay. So in this one, the first question is, this is not about batteries. This is about reaction rates. We haven't had our quiz on batteries yet. So this one is asking you, how do we speed up reactions? 5 different ways. So the first and easiest one is for us to talk about temperature. Hold on, my pen width is a little thin, so let me increase that. Temperature. And then pressure, you could have talked about volume. Either way would have been fine. A catalyst, concentration, and then surface area. Those are all the different ways in which you can speed up a reaction. Okay, so moving down to the bottom one where we actually then analyze the math associated with it. So in this one, we are trying to figure out what is the rate law, generic, and then what is then the actual rate down here at this question mark. Okay, so all we've got is this data in this table. And what we need to understand is that the rate law essentially has this formula of A to the X, B to the Y. In this case, this is my A, this is my B. Okay, so we need to find where the reaction does not change concentration for one of the A or the B. So we'll start with A, and we'll look for a place where B does not change. So that happens on experiments 1 and 2. So what we're going to do is we're going to take then this larger value on experiment 2, 3, divided by 1.5 in experiment 1. We're going to set that equal to the x power, and then we're going to use these exact same ratios. So 7.4 times 10 to the negative 7 over 3.7 times 10 to the negative 7. Now, what happens when we have these exponents that are the same is we get the privilege of just simply canceling those out. So 3 divided by 1.5 is 2 to the x, and 7.4 divided by 3.7 is 2. So my value for x comes out to be 1. Okay, now for solving for B, for Y, we got to find a place where the two values are held constant in A, and that's happening on experiments 2 and 3. So here is where I'm going to take my difference, 4.5 over 1.5, and that's to the Y power. And then we will keep the same pattern of large value over the top. Now this time, the exponents are different, so it might be easier just to put those into the calculator. But reality is this is 2.2 divided by 0.74. But if we just put it into the calculator the way it is written, you'd still get the same answer. So I've got 4.5 divided by 1.5 is 3, and that's to the Y power over 2.2 over 7.4, and that is also equal to 1. Okay, so nothing really changed. 7.4 divided by 3.7. Make sure I'm doing everything right. Yeah, everything is looking out right. So our Y value and X value are both equal to 1. So that's not going to change our exponents. So now what we've got to do is solve for a K. So what we can do here is we can plug in any of this data into any of the experiments, 1, 2, or 3. I'm just going to choose 1. So I've got 1.5 to the 1 power, because I now know that my x is equal to 1, times 1.5 to the 1 power, because y is equal to 1. The k is in front, and the rate for this one is 3.7 times 10 to the negative 7. So I'm going to isolate, divide both sides by 1.5 and 1.5. So I've got 3.7 to the exponent of negative 7 divided by 1.5 divided by 1.5, and you get k is equal to 1.6 times 10 to the negative 7. Now that we have our value for k, we can now go ahead and do the final step, which is let's solve for the rate of experiment number 4. So I've got let's start with the k. K is equal to 1.7 times 10 to the negative 7, 4.7 to the power of 1, 2.7 to the power of 1. So I've got that k value times 4.7 times 2.7, and you end up with 2.1 times 10 to the negative 6. All right, this is everything that I wish to help you with on this quiz. Thank you so much for taking your time to try and make your corrections. Now you can start on some of the practice problems. Talk to you soon. Bye-bye.